Okay, so today we're going to look at angle of elevation and depression. Now, this is a very interesting topic. At the same time, it's a very lengthy topic. So we'll just be taking it like one after the other. Um, so basically, what is angle of elevation or an angle of depression? Now, supposing we have, let's say, man. Uh, so I'm going to do some very funny things here. So this is a man here, and then there is a hill here, and then let's say there is another man at this point here. Okay, so now angle of elevation tells you that uh, this man looks at another man at an angle at this point here. So let's call the angle theta. So the angle at which man at the ground looks at another man um, on top, let's say a hill or a mountain or whatever, is called the angle of elevation, and it's represented by theta here. Now, also, the man on the mountain on the high um, point there looks at the man on the ground at um, an angle too, and that angle the man looks at the other man on the ground is what we know as the angle of depression. So we're going to call this phi. So this from the man on the ground to the man up, angle of elevation. From the man up to the man on the ground, angle of depression. Now, if you notice very well, um, angle of elevation is when you look at somebody up, and when you look at somebody down, then you are looking at an angle of depression. But very obviously, you see that from your knowledge of angles, the angle of depression and the angle of elevation actually equal angles because they alternate each other. They are alternating angles. So that means theta is equal to phi. And we know that theta is angle of elevation, right? And we know that phi is angle of depression. Okay? So this is something that you should know because you'll be applying this a little bit more when you are solving angle of depression. You have to take note of these alternate angles here. Okay? Now, let's see an example so that we can really apply these things. In the examples we're going to be solving, you'll be seeing examples involving solving triangles. So be creating diagrams, and from the diagrams, we'll be finding angles, we'll be finding sides, we'll be finding length of elevation and stuff like that. So your idea of or your knowledge of solving triangles on triangles should be able to help you solve angle of elevation depression. Now, in angle of elevation depression, we have questions involving single triangles. Now, there are other complex questions that involves double triangles. There are other questions that involve elevation, other questions involve depression. And there are questions that are complex that you really have to think. So we'll be going through all of this in the process of solving angle of elevation depression. Well, let's look at one example first. So I'm going to look for um, kind of example that will be okay for us to solve. So the question says, I wish I had written this earlier. So if the shadow, okay, of a pole 7 meter high, all right, is half its length, okay, um, what is the angle of elevation? of the sun. Now, this is a little bit complex, because we've not solved um, the simpler part of angle of elevation and depression. Let's still try it out. Let's see if we'll be able to bring out something. Now, basically, for you to be able to solve angle of elevation and depression, you need to understand the question. Then you need to draw your diagram based on the question, and then you start solving. Now, the question says if the shadow of a pole is 7 meter high. So the shadow is 7 meter high. And you notice that if we have a pole, okay, so let's go back this way. If you have a pole, let's say this is a pole here. Okay, so let's say this is a pole. Okay, so now a shadow of a pole normally would be on the ground. So it would be somewhere like this, maybe here, and probably longer. Okay, but they said that the shadow of the pole is 7 meter. Shadow of a pole 7 meter high is half its length. So basically, if the shadow of the pole is 7 meter high, so that's what we need to take note of. Pole is 7. Let me use this. If you don't understand how the pole is 7 meter high, then I will explain that. But basically, understand that the question is a continuation up to the point of the comma here. So it says if the pole of the shadow of a pole 7 meter high is half its length. So meaning that the shadow is half the length of this pole that is 7 meter high. That is the question. So first of all, they told you that the pole is 7 meter high, but when they started with the shadow, they're only telling you that they're getting to the point where they'll mention the length of the shadow, which is half the length of the pole. Did that make sense? Okay. So basically, the shadow is half the length of the pole because they said of a pole 7 meter high. So that means half of 7 meter will give you the shadow, and the shadow would be 3.5 because half of 7 is 3.5. So the shadow is 3.5 meters. Now, what is the question? They have just given us the information. Now, the question is, what is the length of elevation of the sun? Now, basically, for you to get a shadow, you should have a sun. So the sun could be possibly here. Let's say the sun is here. Okay. So that means from the shadow to the sun, guess that's the question. The angle of elevation of the sun. So from the ground to the sun, that is the angle of elevation. So we talked about that angle of elevation is from ground looking up. So from the ground to the sun, from this point to the sun, um, so is the angle of elevation. So how can we find the length from the ground to the sun? Okay, so that is the point. I think it's the length, right? Okay, the angle of elevation, not the length. Sorry, angle of elevation. That's what we're looking at. So this is the angle we're looking for. And we talked about that angle of elevation. It's at this point when we looked at this. Yes, we looked at this. So you should be able to understand this. So this is what we're looking for, the angle of elevation. Now, your knowledge of how to solve triangles should be able to help you solve this. Now, we're going to be using the trig ratio, soc à trois, and we already know what this side is, which is the opposite. So 7 is the opposite, and we know that this side here is the adjacent. So opposite of adjacent is actually tan theta. So we have 2r, which is, oh, let me just do this. Tan theta. So tan theta, which is what we're looking for theta, is opposite 7 of adjacent 3.5 meters. So that means theta is equal to the inverse of tan 7 over 3.5. All right. So now 7 over 3.5 is 2.00. So that means we have theta is equal to inverse of tan 2.000. So this will give you what? Theta will now give you what? This is equal to 63.43 degrees. And that is your answer. This is the angle of elevation. So from this, you see very clearly that if you just understand the question exactly as it is, Then you bring out the question by drawing your diagram. Then after that, you start solving. And if you understand triangles based on your diagram, then you should be able to get your answer. Basically, you'll be using trig ratios, SOHCAHTOA, and the rest to be able to find angles. Sometimes you may have to use Pythagoras theorem to find sides if need be. That will be later on. But I think this is the basic idea of angle of elevation and depression. I think the next question we'll solve is on depression, but that'll be in the next video.